Hi everyone, how are you? Welcome back to my another video on calculus, and for watching my next videos you can subscribe this YouTube channel. In this video we're gonna solve some calculus problems which are about inverse functions, so let's start them. The first question, prove the given derivative formula. The formula is the derivative of the inverse function of sine x with respect to x equals 1 over square root of 1 minus x squared. Before proving this formula, we know that the function of y equals sine x, its graph is like this: pi over 2 pi the sine x in pi over 2 equals 1, and in negative pi over 2 equals negative 1, and in 0 equals 0, and in pi equals 0, and in negative pi equals 0. So we have a graph like this. And we know that this function is one-to-one only in negative pi over 2 to pi over 2. So the inverse function of y equals the inverse function of sine x have a graph like this: pi over 2 negative pi over 2 and this is the graph for the inverse function of sine x. And for this function the domain is x is greater than or equal to negative 1 and x is less than or equal to 1, and the range is y is greater than or equal to negative pi over 2 and y is less than or equal to pi over 2. So when y equals inverse function of sine x, we can write x equals sine y, and we know that the derivative of y with respect to x equals 1 over the derivative of x with respect to y. So the derivative of x with respect to y equals cosine y, and the derivative of with respect to x equals 1 over the derivative of x with respect to y, which equals 1 over cosine y, and cosine y squared plus sine y squared equals 1, and cosine y squared equals 1 minus sine y squared. So cosine y equals positive and negative square root of 1 minus sine y squared. And we know that when y is between negative pi over 2 and pi over 2, cosine y is positive. So cosine y is greater than or equal to 0. So cosine y equals square root of 1 minus sine y squared, which equals square root of 1 minus sine y equals x and x squared. So the derivative of y with respect to x equals 1 over cosine y, which equals 1 over square root of 1 minus x squared. And here the formula is proved. The next formula is the derivative of the inverse function of tangent x with respect to x equals 1 over 1 plus x squared. And we know that the function of tangent x have a graph like this, and actually y equals sine x over cosine x. So the graph for tangent x is like this. And in this domain, a negative pi over 2 and pi over 2, the function of tangent x is 1 to 1 and is inversible. So the inverse function of y equals inverse function of tangent x its graph is like this. This is x and this is y. So the domain of the inverse function of tangent x equals the range of the function of tangent x. So x includes every number, and the range is the domain of the function of tangent x. So y is greater than negative pi over 2 and is less than pi over 2. Then y equals the inverse function of tangent x, and the derivative of y with respect to x equals 1 over the derivative of x with respect to y, and tangent y equals x, and the derivative of x with respect to y equals secant y squared, which equals 1 over cosine x squared, and it equals sine x squared plus cosine x squared over cosine x squared, which equals tangent x squared plus 1. it equals x squared plus 1. So the derivative of y with respect to x equals 1 over the derivative of x with respect to y, which equals 1 over secant y squared, which equals 1 over x squared plus 1. And here the formula is proved, and the derivative of inverse function of tangent x with respect to x equals 1 over x squared plus 1. The next formula is the derivative of the inverse function of cotangent x with respect to x equals negative 1 over 1 plus x squared. And we know that the function of y equals cotangent x have a graph like this. And we know that y equals cosine x over sine x. And when x equals pi over 2, y equals 0 over 1, which equals 0. And the inverse function of y equals the inverse function of cotangent x. Its graph is like this. And we know that in the function of y equals cotangent x, the domain is x is between 0 and pi, and the range is y is between negative infinity and infinity, and y includes all the numbers. And we know that in the function of y equals cotangent x, for the domain of x is between 0 and pi, the function is 1 to 1, and it is inversible. So x includes every number, and y is greater than 0 and is less than pi. Then y equals the inverse function of cotangent x, and the derivative of y with respect to x equals 1 over the derivative of x with respect to y, and we know that x equals cotangent y. So the derivative of x with respect to y equals the derivative of the cotangent y, which equals negative cosecant y squared, which equals negative 1 over sine y squared, which equals negative sine y squared plus cosine y squared over sine y squared, which equals negative 1 plus cotangent y squared. And we know that the derivative of y with respect to x equals 1 over the derivative of x with respect to y, which equals 1 over negative 1 plus cotangent y squared, which equals 1 over negative 1 plus cotangent y equals x, so x squared, and the final result is negative 1 over 1 plus x squared. And here the derivative formula is proved, and we can write the derivative of the inverse function of cotangent x with respect to x equals negative 1 over 1 plus x squared. And the last formula is the derivative of the inverse function of cosecant x with respect to x equals negative 1 over absolute value of x times square root of x squared minus 1. And we know that the function of y equals cosecant x have a graph like this, and y equals 1 over sine x and cosecant x in 0 is infinity, and cosecant x in negative pi over 2 equals negative 1, and in 0 goes toward infinity. So in this domain x is greater than or equal to negative pi over 2 and is less than or equal to pi over 2, the function of y equals cosecant x is 1 to 1, and in other words it is inversible, and its range is y is less than or equal to negative 1 and y is greater than or equal to 1. And for the inverse function of y equals the inverse function of cosecant x the domain is x is less than or equal to negative 1 and x is greater than or equal to 1, and the range is y is greater than or equal to negative pi over 2 and y is less than or equal to pi over 2. So the graph is like this. In x equals 1, the y equals pi over 2, and the graph is like this. and in -1 the function equals -pi/2, and the graph is like this. And here we want to find the derivative of the inverse function of cosecant x. So y equals the inverse function of cosecant x. So the derivative of y with respect to x equals 1 over the derivative of x with respect to y, and we know that x equals cosecant y, and the derivative of x with respect to y equals the derivative of the cosecant y, which equals negative cosecant y times cotangent y. And we know that cosecant y squared equals 1 over sine y squared, which equals sine y squared plus cosine y squared over sine y squared, which equals 1 plus cotangent y squared. So cosecant y squared equals 1 plus cotangent y squared, and cotangent y squared equals cosecant y squared minus 1, and cotangent y equals positive and negative square root of cosecant y squared minus 1. And we know that the derivative of x with respect to y equals negative cosecant y times cotangent y. And we want to find the result of multiplication of cosecant y and cotangent y. So cosecant y times cotangent y when y is greater than or equal to -pi/2 and is less than 0, and cosecant y times cotangent y when y is greater than 0 and is less than or equal to pi/2, and when y is greater than or equal to -pi/2 and is less than 0, cosecant y is 1 over sine y, which is negative, and cotangent y, which is cosine y over sine y, is -2. So the result is positive. And when y is between 0 and pi/2, cosecant y is 1 over sine y is positive, and cotangent y is positive 2. So the result is positive. So the derivative of y with respect to x equals 1 over derivative of x with respect to y, which equals 1 over negative cosecant y times cotangent y, which equals negative 1 over cosecant y times positive and negative square root of cosecant y squared minus 1. So the derivative of y with respect to x equals negative 1 over x times positive and negative square root of x squared minus 1, and we know that the result of x times positive and negative square root of x squared minus 1 is a positive number, and we can write them in absolute value. So the result is negative 1 over absolute value of x times positive and negative square root of x squared minus 1, which equals negative 1 over absolute value of x times square root of x squared minus 1. And here the formula is proved successfully. We finished all these problems, and I wish you every success. Thanks for watching. Bye.